Good morning. Today we're going over our first practice exam in preparation for our first exam. And this practice exam should be very helpful for you in preparing for the exam. In particular, the practice exam, the concept study guides, and the worksheet should all be great. But the practice exam is going to put all this into a format that's going to be familiar then when you get to the exam. I'm going to ask kind of the same spread of questions that you can expect to see on the exam. So I hope this is helpful, and let's get started. The first question is asking if density would be classified as a chemical property, an intensive property, an extensive property, or a state of matter. And so of those four, first of all, we can eliminate a state of matter because that's solids, liquids, and gases. And then looking at the rest of those, chemical properties are those which change the substance while you measure it. So if you're measuring density of something, you're not actually changing the substance of that thing. So density is not a chemical property. Intensive and extensive properties are properties which either do not depend on the amount of substance or do depend on the amount of substance that you are measuring. So to give an example, mass would be an extensive property because the more of something you have, the higher the mass. So that property changes depending on how much you have of it. Whereas the color of something doesn't change depending on how much you have. Like milk is white, depending on whether you have a cup or a gallon, it doesn't make a difference. It's still white. So that's an intensive property. So looking at density, density is actually a ratio of mass to volume. Mass and volume are both extensive properties, but when you take the ratio of those two, then it becomes an intensive property. It is independent of the amount of that thing you have. Next, which of the following samples will, by definition, have a constant composition? What we're looking for here are pure substances. Pure substances have a constant composition and unique properties. That is the definition of a pure substance. And the types of matter which we look at as being pure substances, that is those which have constant composition and unique properties, are elements and compounds. So we're only looking for elements and compounds here. We can eliminate anything that is a mixture. So oxygen is an element. It's on your periodic table, which is given to you. Kool-Aid is a mixture. Water is a compound. You should know that. It's kind of common knowledge. And finally, vanilla ice cream would be a mixture. So these are the only two which have constant composition because they are elements and compounds, which are pure substances by definition. Precision refers to how close a measured number is to other measured numbers. If they are very close, then you get to retain additional significant digits. Accuracy would be the right answer for this bottom one. That is how close a measured number is to the true value. If an object has a mass of 40 grams and occupies a volume of 9.51 milliliters, the density is what? Note that we do not give you a formula for density anywhere here. If you look at the answers, though, you can see, oh, they want units of grams per milliliter, grams divided by milliliters. I have grams, I have milliliters, I can put that together. 40.1 grams divided by 9.51 milliliters. I'm just setting this up so that the units end up exactly where I want them to be. 40.1 divided by 9.51 gives me a density of 4.22 grams per milliliter. I don't want you to use a formula. I want you to be able to use dimensional analysis on these types of problems. For this conversion, I give you meters per second and I ask for kilometers per hour. 5.07 meters per second. So I have to convert the meters to kilometers and the seconds to hours. Okay. Meters to kilometers. There are 1,000 meters in a kilometer. Great, that's done. And to get from seconds to hours, there are 60 seconds in 1 minute. You need to know that. And hopefully you know there are 60 minutes in 1 hour. So my seconds cancels and my minutes cancel. And now I'm left with units of kilometers per hour. So 5.07 divided by 1,000 multiplied by 60 multiplied by 60 gives me 18.3 kilometers per hour. Next, if a 130-pound woman takes 2 325 milligram tablets of acetaminophen, what is the dosage she receives in grams per kilogram of body weight? You can see again here, my answers. We want gram per kilogram, and that's grams of acetaminophen per kilogram of the body. That's our target. So first of all, let's take 130 pounds and convert to kilograms. And I would give you, this is the practice test, so I didn't give you this conversion, but I would give you a conversion from pounds to kilograms on the test. And we see that you've got 2.2 pounds in 1 kilogram. And if I do this, I'll do this stepwise, might be a little bit easier for you to see. 130 divided by 2.2 gives me 59.1 kilogram woman. That's the body. And if we say, look, she's taking 2 tablets, acetaminophen, and every 1 tablet has 325 milligrams of acetaminophen. They want grams, not milligrams, so there are 1,000 milligrams in 1 gram. Tablets cancels, milligrams cancel, and I get 2 tablets multiplied by 325 milligrams per tablet divided by 1,000 milligrams in a gram, and I get 0.65 grams of acetaminophen. Now, if they want grams over kilograms, and I found kilograms of my body and grams of my acetaminophen, then 0.65 grams of acetaminophen divided by 59.1 kilograms of my body will give me my answer in the units I asked for. And I get 0.0109. Looks like that. In question 7, we're looking at penicillin. And we see that the recommended adult dosage for penicillin is 0.01 grams per kilogram. So the question is, how many 150 milligram tablets would a 32-pound child have to take to receive the same dosage? So let's start with what we're given, 0.01 grams of penicillin per kilogram of that body weight. Now we've got a 32-pound child, so we're going to have to use the fact that 1 kilogram is 2.2 pounds. And I'm going to put the 1 kilogram on the top. So those cancel. This is a 32-pound child. Okay, so now we've got the amount of penicillin that she needs to take in grams. And we are taking 150 milligram tablets. So let's convert this to milligrams. 1,000 milligrams in a gram. You do need to know that because that's metric. And finally, we have 150 milligram tablets. 150 milligrams in 1 tablet. Penicillin. So grams of penicillin cancels, milligrams of penicillin cancel, and we're left with tablets of penicillin. Plug this in. 0.01 grams of penicillin per kilogram of body weight divided by 2.2 pounds per kilogram of body weight multiplied by 32-pound person multiplied by 1,000 milligrams in a gram and divided by 150 milligrams in a tablet gives me what's close enough to 1 tablet. Next, the metric unit used to measure volume is the liter. The gram is the metric unit for mass. Kelvin would be for temperature. Gram per cubic centimeter is density and meter is distance. Converting this to scientific notation, if I put a decimal point here and I move it over, I'm going to move it over by 1, 2, 3, 4, 5, 6. So that is 1.45 times 10 to the 6th. Which of these represents the largest quantity? This was a homework problem. We can do this. 4.73 times 10 to the negative 6th kilograms, and kilo means 10 to the 3rd. So when I insert 10 to the 3rd, 10 to the negative 6 times 10 to the 3rd gives me 4.73 times 10 to the negative 3rd grams, 47.3 milligrams Milli means 10 to the negative third, so that is 47.3 times 10 to the negative third grams. 4730 nanograms. Nano means 10 to the negative ninth. So this is 4730 times 10 to the negative ninth grams. And here, this next one, 4.73 times 10 to the negative fourth grams. And our last one, 4.73 times 10 to the third micrograms. Micro means 10 to the negative sixth. So 10 to the third times 10 to the negative sixth gives me 10 to the negative third. All right, now that I've converted all of these to the same base unit of grams, I can start eliminating some of these and or converting some of these to more convenient power of 10 units. They want to know which one is the biggest. So just looking at, say, between these two, 4.73 times 10 to the negative fourth versus 10 to the negative third, this one is smaller, so we could eliminate that. These two are the same, 4.73 times 10 to the negative third, but this one is 47 times 10 to the negative third. So this is bigger than those two, which are the same. And now this one I'm going to bring back 1, 2, 3, 4, 5, 6 positions. And that would give me 10 to the negative third instead of negative ninth because I moved it by 6. So 47.3 times 10 to the negative third is definitely bigger than 0.00473 times 10 to the negative third. So this is the right answer. So again, note how I moved it from our prefix notation back to our base notation of grams, and then I was able to compare some and move some to the same power of 10 to compare the size. Next, if gasoline sells for 95.4 cents per liter, and remember, anytime they say per, that means divided by. They want to know what this is on a cost per gallon basis, and you can see here they give dollars, so they want dollars per gallon. And again, I think this was a homework question, and I do give you conversion between liters and quarts and gallons and quarts. So let's start here, 95.4 cents per liter and 100 cents and a dollar. Let's get that taken care of. So our cents cancels. We have dollars on top, which is what we wanted. All right, now we need to go from liters to gallons, and I'm given liters to quarts, so let's try that. 1 liter goes on top, 1.06 quarts on the bottom. And then finally 4 quarts, put that on top, is 1 gallon. And if I do that, my quarts cancels, my liters cancel, and I'm left with dollars over gallons. So I could just plug this in. 95.4 cents per liter divided by 100 cents in a dollar divided by 1.06 quarts in a liter multiplied by 4 quarts in a gallon, and that gives me $3.60 for the price of gasoline. Now I've got a conversion between grams and grains. Grains being a somewhat archaic measuring unit. But if we start with 0.500 grams, and I tell you how many milligrams is in a grain, that tells you you're going to have to go from grams to milligrams. So 1 gram is 1,000 milligrams. And 1 grain, put this on top, is 64.8 milligrams. I did that so my milligrams would cancel, grams cancel, and I'm left with units of grains. That gives me 7.72 grains. Okay, now we're on to atoms in the periodic table. The number of protons in the nucleus of the atom is called the atomic number. That's also the number that's top and center right here. That's the atomic number, and that's the number of protons. The atomic size of atoms, that is radius, changes as we go down. It gets bigger, and as we move across, it gets smaller. So it increases going down in a group, and it decreases going across in a period. Again, it increases going down in a group because we are going from smaller size shells to larger size shells, and decreases as we go across because we're filling the same shells, but then they are being held more tightly. The symbol for the element calcium is Ca, and again, for all of these, you do not have to memorize because you have the periodic table with you on the exam, which has the names of the elements as well as the symbols. So you should never get this type of question wrong because you can just look on the periodic table and see, oh, calcium is Ca. This is given to you, and you have as much time as you want on the test. It's not even timed, so you have plenty of time to look at this and make sure you get the right answer. All right. Now looking at weighted atomic masses, we've got element XQ. And you've got XQ with a mass of 100 atomic mass units and 102 atomic mass units. And if you've got 20% of this and 80% of this, then in order to calculate the atomic mass weighted for abundance, we're going to multiply 100 by 0.2, 102 by 0.8, that's the fraction, and then add them together. So 0.2, that's 20% of 100, plus 0.8, that's 80% of 102, gives me a sample with an average mass of 101.6. Now question 17, I'm given an isotope with a certain number of neutrons, a certain number of electrons, and a particular charge. And they want to know what the number of protons is. And so what you need to know is that protons will contribute to the overall mass with the neutrons and the overall charge with the electrons. Since I didn't give you any information about mass, then this information about the number of neutrons is actually not helpful. If you had the mass, you could calculate the protons from that if you knew the neutrons, but we don't have that. So this is just extra information meant to distract you. But you do know that the number of protons minus the number of electrons gives you the charge, because if you have extra electrons, you'll have a negative charge. If you have fewer electrons than protons, you'll have a positive charge. So this tells me I have 6 more positive charges or 6 more protons than I have electrons because they have negative charges. So if I have 68 electrons, then I must have 74 protons. All right, next, how many protons, neutrons, and electrons respectively does this element have as shown? Because there's no charge, you know the protons are the same as the electrons. And this number in the bottom left is the atomic number or the number of protons. So you have 53 protons and 53 electrons. And we're going in order, protons, neutrons, electrons. You want something with 53 at the beginning and 53 at the end, and that actually eliminates everything but this. But just to make sure we're doing it right, the total mass up here, 127, needs to be the sum of the protons and the neutrons. And we know we have 53 protons, so mass of 127 minus 53 protons gives me 74 neutrons. So yes, I'm sure I got that right. Next, what is not a property of metals? Metals do conduct electricity. They are shiny. That's what luster means. They can be drawn out into a thin wire. That's what ductile means. And they can be hammered flat. That's what malleable means. They're not brittle. I should say they're not generally brittle. All right, next, what describes a proton? It's got a charge of 1 and a mass of 1, and it's in the nucleus. So right there. If I asked for an electron, you'd say a mass of 0, charge of -1, and outside the nucleus. So this describes an electron, right? And a neutron would be a mass of 1, charge of 0 inside the nucleus. So this describes a neutron. If I add a proton, then that increases the atomic number, and it would obviously also increase the atomic mass because protons have mass. And because it changes the number of protons, it would actually change it to a different element because the number of protons defines what elements you have. So that would actually convert it to an atom of a different element. And lastly, Which of the following elements has 4 valence electrons? Again, this is a question everybody should get right. You just look at the periodic table, you find group 4. 1, 2, 3, 4. These are the elements which have 4 valence electrons: carbon, silicon, germanium, tin, and lead. So silicon it is. Hydrogen and sodium are in group 1, so they have 1. Magnesium is in group 2, so it has 2. And sulfur is in group 6, so it would have 6. That is it, guys. You can do this. The math problems tend to be a little bit difficult if you're new to dimensional analysis, but practice is the key, and watching your units. That's the whole point of dimensional analysis. I hope this was helpful, and I hope you have a great day.